Hi, I am Lady Darilyn Bihavier from the SCS 3B, and I will tackle about granularity and what is different types of granularity. But before that, what is granularity in computational or communication ratio is? In parallel computing, granularity is a qualitative measure of the ratio of computation to communication. Periods of computing are typically separated from periods of communication by synchronization event. So, in the classical sense, it is the breaking down of larger holistic tasks into smaller, more finely delegated tasks is called granularity. It can inform development practices and direct design for technologies by bringing attention to how computing tasks work in the context of an entire project. So, in fine-grained parallelism, relatively small amount of computational work done between communication events, low computation to communication ratio, facilities load balancing, implies high communication overhead and less opportunity for performance enhancement. If granularity is too fine, it is possible that the overhead required for communication and synchronization between tasks longer than the computation. So, a program is split down into a larger number of a little tasks in fine-grained parallelism. Many processors are assigned to these duties simultaneously. So, a parallel task involves a little quantity of work that is evenly allocated across the processors. As a result, fine-grained parallelism makes task schedules easier. So, an example of fine-grained system from outside the parallel computing domain is the system of neurons in our brain. So, in coarse-grained parallelism, relatively large amount of computational work done between communication, synchronization event, high computation to communication ratio implies more opportunity for performance increase harder to load balance efficiently. So, in a program is divided into large tasks in coarse-grained parallelism. As a result, processors perform a significant amount of computation. This could lead a load imbalance with some jobs processing the major of the data while others sit idle. Furthermore, because most of the computation is performed consecutively on a processor, coarse-grained parallelism fails to use the parallelism in the program. Low communication and coordination cause are advantage of this sort of parallelism. The granularity of data refers to the size in which data fields are subdivided. So, for example, a postal address can be recorded which coarse granularity as a single field. Address equals 200 2nd Avenue. So, in medium-grained granularity is a compromise between fine-grained and coarse-grained parallelism, where we have task size and communication time greater than fine-grained parallelism and lower than coarse-grained parallelism. Most general-purpose parallel computers fall in this category. So, in comparison to fine-grained and coarse-grained parallelism, medium-grained parallelism is applied. Medium-grained parallelism is a balance between fine-grained and coarse-grained parallelism, which task size and communication times that are larger than fine-grained parallelism, but smaller than coarse-grained parallelism. This is where most general-purpose parallel computers belong. Intel IPSC is an example of medium-grained parallel computer which has a grain size of about 10 ms. So, which is best? The most efficient granularity is dependent on the algorithm and the hardware environment in which, in the most cases of the overhead associated with communication and synchronization is high relative to execution speed, so it is advantageous to have coarse granularity. Fine-grained parallelism can help reduce overheads due to load imbalance. So that's all. Thank you.